Hello students, I am Anshu Singh, PhD Physics from GMP Indore. How is your work going on? And in your studies, you are really working hard, isn't it? We teachers are also working hard, preparing notes, taking online classes, collecting material, attending webinars. Hold on. We are working hard, but we are not doing work at all. Now, we will discuss that work is different from working hard. Work in terms of physics needs two conditions to be satisfied. Number one is force, which is applied by this man. Number two is the displacement of the box on which this force is applied. If they are acting along same direction, like this, if I am pulling this block in this direction and the displacement is also along the same direction, that means the formula for work done in these cases is equal to W is equal to F into S. See here, I am lifting up this ball. I am applying force in upward direction. The displacement of the ball is also in the upward direction. So work done is W is equal to F into S. But what happens if I apply force like this? Displacement is again horizontal to the surface and the force is along this string. So if force and displacement are not acting along same direction, that means we are not using the same formula which is for same direction of force and displacement. The formula changes and the formula becomes W is equal to Fs cos theta. We have this formula here, W is equal to Fs cos theta. That means now work depends on three quantities. Number one, force. Number two, displacement. And number three, the cosine of angle between force and displacement. Depending upon these three factors, force, displacement and cosine of angle between force and displacement, that is cos theta, work can be zero, can be positive and can be negative. Let us start with zero work. Zero work can be due to either of these three quantities. If F is zero, work done is zero. If displacement is zero, work done is zero. If cos theta is zero, work done is again 0. Now let us start with first condition, when no force is applied, and that's why work done is 0. Suppose you are drawing, suppose you are doing meditation, suppose you are reading, suppose you are writing. That means you are not applying any force. So that's why work done is 0. What is the second condition? Let us move to condition number 2. When you are applying force, but displacement is not there. See, I am applying force, but this table is not displacing from its position. No displacement. And if no displacement is there, that means work done is 0 due to 0 displacement of object. This ball is not moving. What are the other conditions in which displacement is 0 even when force is applied? Other conditions are a man standing on ground, on surface, and he is holding a bag. He is applying force, but no displacement is there. And if we are sitting or standing at a particular place with a luggage, then no work is done by him because he is not showing any displacement. Again, let us move to circular motion. Moon is revolving around the earth. Planets are revolving around the earth. One athlete is running on a circular path. You tied one stone with a string and then you are whirling it. We have studied this in uniform circular motion. So after one complete revolution of moon or planets or stone or athlete, what happens? What is your displacement? The displacement is 0 and that's why work done is 0. Third condition is when the angle between the two is 90 degree because the cos of 90 is 0. See here, this block is again displaced but I am applying force in this direction. And when I am applying force in this direction, displacement is again parallel to the surface. And that's why angle between force and displacement is 90 degree. Whether it is upward or downward. Force and displacement are perpendicular to each other and cos 90 is 0. So work done is 0. Let us see one more example. In every case, the person holding the luggage or the box or the books on his hands and moving ahead in the forward direction. This coolie is carrying luggage on his head and moving in forward direction. This man is carrying suitcase and again moving in forward direction. In each case, the force and displacement are perpendicular to each other, and due to this condition, work done is again 0. We have discussed just now that after one complete revolution, displacement is 0. That's why work done is 0. What happens if 2 revolutions are there? Again displacement is 0, so work done is 0. What happens after 100 revolutions? Work done is again 0 because displacement is 0. Now what happens if we are talking about only 1/4 of the revolution? For the 1/4 revolution, what will happen? Anybody, if it is moving on a circular path, there is one force which is always directed towards center. This is known as centripetal force. Centripetal force is always acting towards the center of the circular path, and the displacement is tangential to this circular path. That means they are always perpendicular to each other. So whether the revolution is 1 or 2 or 100, the work done is 0 of course. But if the revolution is half or 1/4 or 1/6 or whatever it is, the displacement and force, they are always perpendicular to each other. When a body is moving on a circular path, that means work done is again 0 due to cos 90 is 0. So the work done by centripetal force is always 0. Second type of work is positive work. Suppose the angle between the force and displacement is 0. The work done is positive. Angle between displacement and force is 30 degree or 60 degree, or we can call, if the angle between the force and displacement is less than 90, that is acute, then the work done is greater than 0. Because this cos 90 factor, this one, because this cos factor makes, it is in first quadrant because angle is acute. In first quadrant, the value of cos theta is positive. That's why work done is positive. This boy pulling this girl, angle between them is 30 degree or less than 90 degree. So definitely work done is positive here. W is equal to F into S into the value of cos of 30. This horse pulling the cart in forward direction. Both are acting along same direction. Angle is 0 or acute. That's why work done is positive. This boy is lifting weight up. Suppose we are lifting this ball up. Again the same condition. Work done is positive because the angle is acute. That means they are acting along same direction. The value of cos 0 is 1. The apple is falling on the hand of Newton. What does this indicate? The work done by the force of gravity. See here. Force of gravity is acting in downward direction. I am leaving this ball. What is the direction of the ball? Downward. What is the direction of force of gravity? Downward. So, what is work done? Of course, positive. Let us discuss now negative work. We have discussed when angle is 0, when angle is 90, when angle is acute. Now, it is turned for the angle to be obtuse. If the force and displacement, they make angle greater than 90 degree, then the work done is negative. Because the value of cos theta, when it is obtuse, or you can call it when it is in second quadrant, then the value of cos theta is negative. That's why work done is negative. Do you have any example of work negative? The best example is the force of friction. Force of friction always acts in the opposite direction as the direction of motion. You are pushing this box, fine. The work done by this pushing force is positive because motion and force, they are acting along same direction. But what will happen to this frictional force? The work done by this force of friction is negative because motion is always opposite to the direction of friction. That's why work done by frictional force is negative. One more activity. Again, let us lift a ball. Work done by my hand is positive, but gravity is still acting in the downward direction. So work done by the force of gravity, this time positive or negative? It is negative. Work done by my hand is positive. Work done by force of gravity, positive. But when we are moving in the upward direction, then the work done by the force of gravity is negative because force of gravity always acts in the downward direction. Start from energy. We will discuss different forms of energy now.